Hello everyone, welcome back to the channel. This is part 5 of a video series where I'm attempting to explain every Sudoku solve technique. Today we're going to be covering wings and multi-digit chains, and in parts 1 through 4 we covered basic techniques, advanced groups, fish, and single-digit chains respectively. So make sure to check those out. Those will give some really good foundation for the topics we'll discuss in this video, and those will all be linked in the description. Anyway, in the last part we discussed single-digit chains, and we went over strong and weak links, as well as the basics of alternating inference chains, or AIC. And those single-digit AICs are a really powerful technique. But once we consider multiple digits, we could actually open the door to a ton of possibilities. And we could look at the links between different values. That enables us to do multi-digit chains. Wings are a very closely related structure, and they're kind of a much more fuzzy definition. But they're basically a structure where you have two wing cells that are connected by one or more pivot cells. And pivot cells basically just switch from one value to one digit to another. And any candidate that sees both wing cells at both ends can get eliminated. So most wings are multi-digit chains, but there's a few multi-digit chains that aren't called wings, and there's a few wings that don't exactly reduce to multi-digit chain logic. But there's so much overlap that I'm going to be covering both of them in the same video here. Anyway, without further ado, let's get into it. So in order to understand multi-digit chains, we first have to understand links between different digits. In the last part of single-digit chains, we only went over links between the same digit in two different cells. So for example, we have a grid from the Sudoku Coach campaign here, and let's look at the nines, for example. We could say that these two nines are weakly linked because it's the same digit in different cells, and there's 3 of them, and they're in the same row. And these two nines are strongly linked because they're in the same column, but there's only 2 cells, so they're bilocal. Therefore, it's a strong link. But for multi-digit chains, what we need to look at is different digits in the same cell. So we could generally say that every candidate in a cell is weakly linked to every other candidate in that cell, because if one were true, all the other ones would have to be false. So for example, we could say this 9 right here is weakly linked to this 3, this 5, this 4, and this 8. And it looks a little bit difficult to see when you do all of those links at the same time, but the principle still holds. Now, if there are only 2 candidates in a cell or 2 values in a cell, then we could say if one is false, the other must be true, and therefore they are strongly linked. So if we look at this bi-value cell down here, which only has a 1 and a 9, we could say the 1 and the 9 are strongly linked here. And remember, these strong links also function as weak links, because if one is true, the other is false. So I'm going to be calling these links between the same digit in different locations, location links or L links, and these links where it's the same location, the same cell, but different digits, I'm going to be calling those value links or V links. And we can kind of characterize chains by how they structure these different types of links. We also went over group links in the last video, where if you have a group of multiple cells that share the same box and line, then you could treat those as a group and link groups to individual candidates or other groups that share a box and line. So for example, these 2 nines could be seen as a group link with this 9 right here, if we wanted to draw a group right there. For the purposes of this video, we are going to treat group links exactly the same, where we only look at links between single digits. There are ways we could do groups of multiple different digits and link those together, but in order to do that, we have to get pretty deep into ALS logic. And I'm going to go ahead and save that for a future video where we combine, different categories of technique, because that can get real complicated real quick. Anyway, let's look at how we can combine these links to form multi-digit chains. So in addition to characterizing AICs based on the types of links they have, we could also characterize them based on the digits they start and end on. Type 1 AICs start and end on the same digit, and eliminate any candidates that see both ends of the chain. And all of the chains we covered in the last part on single-digit chains were type 1 AICs because there was only one candidate for the chain to start and end on. But this can also happen with multi-digit AICs, where throughout the chain you could bounce between a bunch of different digits as long as you return back to the original digit by the end. So here we have an example of that. This is a grid from Sudoku, and we could actually go ahead and start up here with this 5. It's strongly linked to this 3 because they're by value in that cell. This 3 is in the same row as this other 3, so they are weakly linked. And this 3 is strongly linked to this 3 that's buy local in the column, which is then weakly linked to the 9, which is in the same cell. The 9 is strongly linked to this 9 down here because they're buy local in that column, which is weakly linked to this 2, which occupies the same cell. That 2 is strongly linked to this 2 because they are buy local in that row, weakly linked to this 2 because they are in the same box. And then finally, that 2 is strongly linked to this 5 right at the end because they're buy value in that cell. So we went from 5 to 3 to 9 to 2, and then finally back to 5. So we started and ended on the same digit, despite those multiple digit flips there. And we could eliminate any digits that see both these ends. So that includes these 2 5s right here and these 3 5s right here. And one thing to notice about this chain is all of these value links are sandwiched between location links. And that's just a general thing to kind of notice when it comes to looking at these AICs. You can't have adjacent value links. Anyway, that's type 1 AICs. Type 2 AICs start and end on different digits, and importantly, the ends of the chain must see each other. What you could do is you could eliminate your starting candidate from your ending cell, and vice versa. And this is because that elimination candidate, on the one hand, sees the same digit in your starting cell, but it's occupied by a different digit in your ending cell. So there's no way it can be true. And this is unique to multi-digit chains because you have to switch digits at least once in order to have a type 2 AIC. So let's take a look at this chain right here. This is also another grid from Sudoku. And let's go ahead and start with this 4, strongly linked to this 4 that is buy local in the column, which is weakly linked to this 4 in the same row, strongly linked to this 9, which is buy value in that cell, which is weakly linked to this 9, which is in the same column, strongly linked to this 9, which is buy local in that row, which is weakly linked to this 8 in the same cell. And then finally, that 8 is strongly linked to this 8 in the same column. And so you'll notice that this 4 right here in that cell, on the one hand, sees this 4, which is at the start of our chain, but is occupied by this 8, which is at the end of our chain. So no matter which end of our chain is true, this 4 cannot be true. So we're going to go ahead and eliminate it. And we could say the same thing about this 8 right here. On the one hand, it is occupied by this 4 at the start of our chain and sees this 8 at the end of our chain. So no matter which end is true, we could go ahead and eliminate this 8. And that is how you do type 2 AICs. So the XY-Wing, which is also sometimes just called a Y-Wing, is essentially a bent naked triple, where we have 3 bi-value cells. Each of those is pulling a different combination from the same group of 3 candidates. So here we have a grid from the Sudoku Wiki, and our 3 candidates are 1, 2, and 7. And we could actually look on this grid, and we have a cell here that's 2 and 7, we have a cell here that's 1 and 7, and we have a cell here that's 1 and 2. So notice 3 different combinations of our 3 candidates, 1, 2, and 7, and they form this bent structure here. So we can make an elimination out of this by treating it as a multi-digit AIC. So let's go and start with our candidate of 2 right here and see what links it has. We know it's strongly linked to this 7. And then this 7 is weakly linked to this 7, which is strongly linked to this 1, which is weakly linked to this 1. And then finally, it ends in a strong link with this 2. So you'll notice that this starts and ends on the same digit, which is 2. Therefore, it's a type 1 AIC. And therefore, we could eliminate anything that sees both ends of this chain, which the only thing that sees both ends is this 2 right here. So we'll go ahead and eliminate that. So XY wings are very short by multi-digit AIC standards. You really don't see any multi-digit AICs that go shorter than 5 links. And another important thing to note about the XY wing is that since all of our cells are by value, that means all of our strong links are value links. This is called a wing because we have 2 cells at the ends, our wing cells, and then a pivot cell in the middle. And it's an XY wing because our pivot cell only has 2 candidates, X and Y. But anyway, that is the XY wing. So XYZ wings are very similar in structure to XY wings, except we have three candidates in our pivot cell, hence XYZ. So despite this seemingly minor change, this actually really limits our eliminations because now we can only eliminate candidates that see all three cells. And because of this, XYZ wings can only exist when one of our wing cells is in the same box as our pivot cell. So here we have another grid from Sudoku Wiki. And our candidates that we're focusing on here are 1, 2, and 4. So if we look through this grid, we can actually see this bi value cell of 1 and 4, that's going to be one of our wing cells. This bi value cell of 1 and 2 is another wing cell. And they both mutually see this pivot cell, which has 1, 2, and 4. And if you notice, this wing cell 1 and 2 is in the same box as our pivot cell. And there is one instance of a candidate that sees all three of these cells, and it is the one in this cell right here. So we can go ahead and eliminate it. Now, the reason this works is because if this cell was a 1, then we would be leaving 4 as the only option for this wing cell, 2 is the only option for this wing cell, and then we would have a 1, 2, and 4, which would completely empty out our pivot cell here. So this is why you can't have a 1 that sees all three of these cells at the same time, because we only have 3 candidates. Now, astute viewers will notice that this is actually a type of ALS-XZ technique. If we treat these two cells as our first ALS and this bi-value cell as our second ALS, we could define 2 as our RCC and 1 as our other shared candidate. And we could say that this one in this box would empty out both ALS at the same time, therefore we can eliminate that. And if that sounded like a bunch of gibberish to you, go watch the advanced group video. That will explain a lot more. But overall, the XYZ wing actually has a lot more similarity with ALS techniques than it does with chain techniques, despite the very similar structure to the XY wing. NY wings let us generalize the concept of XYZ wings to include more candidates and more cells. So if we have 4 candidates, for example, we would have to have 4 cells, and we would call this a 4Y wing or a WXYZ wing. So here I have a grid from the Sudoku Wiki, and we can actually see that we have kind of a bent quadruple, 5, 6, 2, 5, 2, 6, 9, and 2, 5, 9. All 4 of those cells contain the same 4 candidates, 2, 5, 6, and 9. But of course, they're not in a single house. So what we could do is we could actually treat these 2 cells as one wing. We'll go and color that blue. And this cell as another wing, we'll color that purple. And we could treat this cell in the middle that connects them both as our pivot cell. Now, the important thing is that our wings can have multiple different cells in them, but all of the wing cells must see all of the pivot cells. And what we could do is eliminate any candidates that would eliminate shared candidates between both of these wings. So the only shared candidate between both these wings is 5. So we could eliminate these 3 5 candidates because they see all the 5s in both these wings. Now, an important caveat is if there's a 5 in this pivot cell right here, then instead of just eliminating from both the wings, we would also have to eliminate from the pivot cell. And in that case, this 5 right here that sees both wings and the pivot cell is the only elimination we can make. And if we want to extend the principle to even more cells, let's say, for example, if one of these cells, let's say this cell right here, had an 8 in it as well, then we would have 5 candidates, 2, 5, 6, 8, and 9. In order to kind of resolve that, we would just have to add another cell. We could actually add this cell right here, which has a 5 and an 8, into one of our wings here. And now we have 5 cells, 5 candidates, and we can eliminate from any cell that would empty out both of our wings. So this cell right here, we can go ahead and eliminate that 8 if that is the case. Now we could also have multiple pivot cells as well. Here we have another grid from the Sudoku Wiki, and we could look at a group of 4 cells here. We have a 3, 4, and 5, a 3, 9, a 5, 9, and a 4, 5, 9. So that's kind of another bent quadruple, and we can make a WXYZ wing out of this by treating both of these cells as our pivots, so I'll color those yellow, and these 2 cells as our wings. And notice how our wings see both of our pivots. And we have 4 cells for 4 candidates. Our wings also share the candidate of 3, while our pivots don't. So what we could do is eliminate any threes that see both those wings, and the only instance where that happens is these threes right here. So you'll notice this is really just a special instance of the ALSXZ rule because we could treat this as one ALS and this by value cell as another ALS, and then treat the 9 as an RCC and the 3 as a shared candidate, and we'd be able to come to that exact same conclusion. But the NY wing lets us do that using a really unique wing structure, which makes it somewhat easier to spot. If NY wings are what happens when you add more candidates to a regular XY wing, XY chains are what happens when you add more links. So instead of just having 3 by value cells, you could have 4, 5, or even more. And you could create really long chains this way. Also, instead of just having to do that bent triple structure that we see with an XY wing, you have a lot more flexibility with XY chains to include whatever by value cells you want, as long as they are by value. So one of the simplest cases of an XY chain is when you're only moving between the same two values. So here we have a grid from Sudoku Snake, and you'll notice we have a lot of by value cells with the values 1 and 7. We have this one, this one, this one, and this one. And you'll notice they're all connected in the sense that they see at least one other cell. So what we could do is we could actually form a chain out of this. Let's start with the 7 down here. We know there's a strong link from this by value to this one, and then this one is weakly linked to this one, goes back to the 7 through the strong link, which goes up to this cell with a weak link, goes back to the 1, we move up to this cell with a weak link, and then finally we go back to a 7. So we start on a 7, end on a 7. That's type 1 AIC. And this 7 right here sees both ends of our chain, so we're going to go ahead and eliminate it. And sometimes this is actually called remote pairs because you'll notice this is the same pair of candidate the entire time. But this kind of XY chain is valid essentially whenever you have those same two values in an even number of cells that are connected. So you can see we have 4 cells here, unlike an XY wing where we only have 3 by value cells. And that allows us to flip between the two numbers and end in the same number that we started with. That only works if you have an even number of cells. But we can also have lots of other examples of XY chains. So here we have an example from the Sudoku Wiki. And we could actually form an XY chain from these cells that I'm highlighting right here. And if we start with this 4 in this by value cell, we know that's strongly linked to the 8, and the 8 is weakly linked to this 8 down here, which is strongly linked to this 1, which is weakly linked to this 1, strongly linked to this 4, which is weakly linked to this 4, strongly linked to this 3, which is weakly linked to this 3, which is strongly linked to this 4 at the end of our chain. So you'll notice we started on a 4 here, we ended on a 4 here. This 4 sees both ends of that chain, so we can go ahead and eliminate it. But this is a 5-link chain, but since all of our cells are by-value cells, and we are just moving between them with weak links, and switching to a different candidate in each cell using our strong link, that allows us to form an XY chain. Now that we've seen a couple examples of chains where all of our strong links are value links and by-value cells, let's take a look at some chains where all of our links are location links and bilocal cells. So the L wing is an example of this, and it's essentially the opposite of an XY wing. Whereas an XY wing is a 5-link chain where we have all of our strong links are value links. An L wing is a 5-link chain where all of our strong links are location links between two bilocal cells. So unlike an XY wing where both of our weak links have to be location links, with an L wing, we actually have a lot more flexibility. We can go from a strong location link to a weak location link or a strong location link to a weak value link. So that gives us some variation in what an L wing looks like. And the simplest occurrence of an L wing is when all of our weak links and our strong links are location links. And that's called an L1 wing because it only has one digit. However, that's basically just a type of X chain, and we kind of went over a lot of examples over the of that in the single digit chain part. So what's more interesting is L2 wings, which have 2 digits, and that's where one of our weak links is a value link. So here we have an example of that. This is a grid from the r/Sudoku subreddit wiki. And let's go and take a look at our sevens. So we'll notice that these sevens in this column are bilocal, so we can go ahead and say they're strongly linked. And we could follow up this strong link here uh, with a weak link between this 7 and this 3, which are in the same cell. This 3 is then strongly linked to this 3 in the same column. It's bilocal in that column, which is weakly linked to this 3 in the same row. And then finally, that 3 is bilocal with this 3 in the same column. And that brings us back to our original box. Um, and you'll notice that this chain starts and ends on a different value. So therefore, it's a type 2 AIC, which means we could eliminate our starting candidate from our ending cell. We started with a 7, which means we could eliminate our 7 from this ending cell. And any L2 wing has to be type 2 AIC because we only have one value link, which means we only switch what candidate we're focusing on once, which means that our starting candidate can't be the same as our ending candidate. But as you see in this chain, all three of our strong links are location links, and one of our weak links is a location link, while the other one's a value link. That's what makes it an L2 wing. We also have an example of an L3 wing. This is where both of our weak links are value links, and this is also a grid from the r/Sudoku subreddit wiki. And let's go ahead and start with our 4. In this bottom left box, you'll notice that these two 4s are strongly linked because they're bilocal in that box. And then we could say this 4 is weakly linked to this 6 in the same cell. This 6 is bilocal in this row, so we have a strong link there. And this 6 in this cell is weakly linked to a 1 in the same cell. And finally, that 1 is strongly linked to another 1 that's bilocal in the box. So you'll notice with this chain as well, it starts and ends on a different value. Therefore, it's a type 2 AIC. We started with a 4, so we can go ahead and eliminate this 4 from our ending cell. And it's called an L3 wing because we went through 3 different candidates, 4, 6, and 1, because we have 2 weak value links. So as you can see, there's a lot of variation in what an L wing looks like, but the defining characteristic is all of our strong links have to be location links. So the S wing, or the split wing, is another 5-link short AIC, where we start and end on a strong location link. But our middle strong link, which is our third link of the chain, is a strong value link. So instead of having a VVV strong link structure like an XY wing or an LLL structure like an L wing, this would be an LVL structure. So here we have another example from the r/Sudoku subreddit wiki. And we'll go and start right here with the 8 in this cell. So you'll see that this 8 is bilocal with this one. So that's our starting strong link. And it is weakly linked to this 8 right here, which is in a bi-value cell. And here we use our second strong link, which is our value link, to switch over to the 4, which is weakly linked to this 4 in the same row, which is finally strongly linked because it is bilocal in this column. So what we could do is this is a type 2 AIC because it starts and ends on 2 different digits. So we could eliminate our starting candidate, which is an 8, from our ending cell. So we'll go ahead and eliminate the 8 from this cell right here. So the S-wing is not as flexible as an L-wing because this middle value link kind of forces our second and our fourth link to be location links. So it's always going to be a strong location link, a weak location link, a strong value link, a weak location link, and then finally a strong location link. So that means it's always going to be split right down the middle, hence split wing. And that means it's always going to have exactly one value link, and therefore it's always going to be type 2. So when it comes to spotting these S-wings, we know we're going to have exactly one bi-value cell, so it helps to start with that. So let's take our bi-value cell. In this case, it's this cell with a 4 and an 8. And let's look at both those candidates to see if this cell sees any strong links with those candidates. So starting with a 4, we know this cell sees the strong link between these two 4s in this row and the strong link between these two 4s in this row. And then moving towards the 8, we know this cell sees the strong link between these two 8s in this row and these two 8s in this column. So now that we've identified these strong links that this cell sees, what we can do is look at if the strong links of one candidate see the strong links of another. So we'll notice that the ends of this strong link and this strong link see each other. And that's how we know we have an S-wing on our hands. And then we can make that same elimination by removing the 8 from the cell. So that is the S-wing. So the W-wing is kind of the opposite of the S-wing in the sense that we start off with value links on both ends, and we have a location link in the middle, making the structure VLV as opposed to LVL. So we have an example of an S-wing here in this grid, which is also from the r/Sudoku subreddit wiki. And let's go ahead and start off with our 4 in this cell. So it's a bi-value cell, so we know that it's strongly linked to this 2. And our 2 is weakly linked to this other 2. And if we look at the 2s in that row, we'll notice there isn't a direct strong link between two candidates, but we could say this 2 is strongly linked to this group of 2s, which I'm going to go ahead and draw out in blue here. So it works the exact same way as a group link would work in a single digit AIC. We could just apply that in terms of multi-digit AICs. And then we could say these 2s as a group are weakly linked to this 2. And then finally, we have a strong link in this bi-value cell between the 2 and the 4. So started on a 4, ended on a 4. This is a type 1 AIC, and we could eliminate any 4s that see both ends. And the only instances of that are the 4s in these 2 cells. So as you can see, V, L, V. That's the W-wing structure. So these V-links on the ends force our second and our fourth links to be location links. So you won't see any variation in the link structure for W-wings. And another thing you won't see variation in is the type of elimination. W-wings are always going to be type 1 AIC eliminations. And this is because there's only 2 value links, and it starts and ends on one of those value links in our bi-value cells. So let's say in our starting cell, we have candidates A and B, and those can be the only 2 candidates. Because of our strong link, we have to start with A, move to B, and then it stays as candidate B throughout the chain until our final bi-value cell. Now, if it was a type 2 AIC, we'd have to start and end on different candidates. So instead of moving back from B to A, we would move from B to a third candidate, C. Now, the problem with this is that even though it can exist, we can't get any useful eliminations out of it. Because in a type 2 AIC, we have to eliminate our starting candidate from our ending cell. If we start with candidate A and our ending cell has candidates B and C, then there's no eliminations that can even take place. So type 2 AICs aren't something that we have to look for when it comes to finding W-wings. We only have to look for type 1. And with type 1, our starting cell and our ending cell will both have candidates A and B, meaning they will be identical. And that actually really helps us when looking for W-wings. So when we're actually looking for a W-wing, we look for a pair of 2 identical bi-value cells. In this case, it's our 2 and 4, these 2 cells. And we look for any cells they are connected by, which in this case is these 2 cells. And we had 4s in both of those a second ago, so I'm going to go ahead and replace those. Now, when we actually look at the connecting cells between our 2 bi-value cells, we want to look at if they have any shared candidates. And the reason that is because if one of those candidates was in one of these connecting cells, it would force both of our bi-value cells to be the same thing. So for example, if there was a 4 in this cell, that would force both of these cells to be 2. And if both of these cells were 2, that would eliminate all of the 2s in this row that are connected by that strong link. So that is how we could kind of find those eliminations for our W-wing, is looking at our 2 identical bi-value cells, looking at the connecting cells, and if placing a value in one of those connecting cells would empty out a row or column of candidates, then we can go ahead and eliminate those. And so in this case, we can make that elimination of the 4s because if a 4 was to go in either of those, that would essentially empty out all the 2s from this row. So that is how we can spot W wings. So now that we've looked at some examples of wings that start and end on the same type of link, let's look at some wings that start and end on different types of links. M wings are chains that essentially have a VLL structure, or if you look at it from the other direction, an LLV structure, where they start on a value link, they end on a location link, and they have a location link in the middle. And another important thing to note about M wings is that they have a weak value link in the chain as well. And I'll explain the reason for this a little bit later. But here we have an example of an M wing from the Sudoku subreddit wiki. So let's go and start off with this cell where it's a buy value with a 1 and an 8. So we know that we have a strong link there between the 1 and 8. And then going from this 8, we could see it's weakly linked to this 8 in the first row. And then looking at those 8s, we realize these two 8s are buy local in the first row. So we have a strong link there. And then we have a weak value link between this 8 going back to 1, which was our original candidate that we focused on. And finally, we could look at this 1, which is buy local in this column. So there we have the strong link that we end on. So you'll notice we started on a 1, ended on a 1. So this is a type 1 AIC. And we can go ahead and eliminate our 1s from any cells that see both ends of the chain. And that would be in these two cells right here. So this is what we call an M2 wing because it involves 2 digits. In our first value link, we switch from digit A to B. But then in our second value link, which is a weak link, we switch back from digit B to A. So we're still sticking with only 2 digits. And that means this is always going to be a type 1 AIC. But we could also have a type 2 AIC where we have 3 digits. So here I have another example from the Sudoku subreddit wiki. And in this example, we're going to go ahead and start with this buy value cell here. Starting on the 8, we could say that it is strongly linked to this 2. And this 2 is weakly linked to this 2 in the same row, which is buy local with this 2 in the column. So we have a strong link there. And then here's where we have our weak value link, where we go to a third digit. That's what makes it an M3 wing. And then finally, you'll notice the third digit, which is a 1, is buy local in the box. So that finishes off our chain. And we could see that both ends see each other, and our starting candidate of 8 can be removed from our ending cell of which has a 1 and an 8. So we'll go ahead and remove that 8. So that's an M3 wing because we went through 3 digits, 8, then 2, then 1. And that's always going to be a type 2 AIC. So there's a little bit more variation in M wings than there is in S wings and W wings, which can make them more common, but it also makes them a little bit harder to spot because there's not necessarily a one size fits all rule. But if we have a buy local cell and we notice that the candidates within that cell have a lot of location links that see the buy value cell, then there's a good chance we have an M wing on our hands. So H-wings or hybrid wings are kind of an odd category because unlike the other wings we've discussed, they aren't limited to a specific strong link structure. They can be kind of be thought of as a miscellaneous group of wings that were coded separately in early Sudoku solvers because they either have a link structure that isn't covered by previous wings or they cover certain exceptions to some of the rules of previous wings. So one of the exceptions we discussed was with the M wings. Now, M wings have a VLL structure, but with the caveat that there is a second weak value link. So what happens if we don't have that second weak value link? Well, then it would technically be classified as an H1 wing, which we have an example of here. This is another grid from the r/Sudoku subreddit wiki. And let's go ahead and start with this 2 in this cell right here. So we'll notice that this 2 is buy local in this row. So we're going to treat that as our first strong link. And we could use a weak link to bring it down to this row right here. And in this row, we can see that this 2 is strongly linked to this group of 2 2s right here. So I'm going to go ahead and draw a box around that group, and we could draw that strong link. And then this group of twos is weakly linked to this two right here, which is finally strongly linked to this three, and that's our singular value link for this VLL structure. Or if we look at it from this direction, LLV. So we started with a 2, we ended on a 3. So that's a type 2 AIC, which means we can eliminate our starting candidate of a 2 from our ending cell. And that is an H1 wing. Now, you might notice that this exact same elimination of the 2 from the cell can occur from just looking at it as a finned X-wing. So if we were to treat these two rows as base sets and these two columns as cover sets with this specific cell as a fin, we would actually be able to make that exact same elimination. And we could say more generally for these H1 wings that they can be replicated by X-wings, whether those are regular X-wings, finned, sashimi, or mutant X-wings. So given that H1 wings can be reduced down to relatively simpler techniques, it really isn't super useful to go out looking for them. And I believe that's part of the reason that they were coded separately in early solvers. Another example of an H-wing that really just reduces down to fish techniques is the H2 wing. So the H2 wing actually has a VVL structure, which we haven't covered in any of the previous wings. But with that VVL structure, we know that our two strong value links are going to have to be in bi-value cells, and thus those must be separated by one location link. So those two bi-value cells must see each other. Now we have two options. Either our bi-value cells can move between three distinct candidates, or they could flip-flop between those same two candidates. And in that case, it'll just be a naked pair. So that is essentially what we have with an H2 wing, is when we start with two bi-value cells that essentially form a naked pair. And then we connect that to a bilocal pair of those cells. So here we have another example from the Sudoku subreddit wiki, and we're actually going to go ahead and start with this naked pair right here. Let's start with this 3 specifically. We know it's strongly linked to this 5, which is weakly linked to this 5, which is strongly linked to this 3. As you can see, going 3 to 5, then back to 3, which is weakly linked to this 3, which is finally strongly linked to this 3. So started on a 3, ended on a 3. We only went through 2 candidates, hence H2 wing. And we can eliminate anything that sees both ends of that chain. So it would be those 3s. Now, we could also really easily mirror this link structure by simply moving our weak link here to be between these 3s. And in that case, we would have started on this 3 and ended on this 3. And then we can make the elimination of this 3, which sees both ends. And you might notice that this is actually a simple X-wing. So though all those eliminations we made can be replicated by just doing an X-wing, which again kind of goes to show that H2 wings are not particularly useful because they could be replaced by simpler techniques. However, if we had a VVL structure that went between 3 different candidates or an H3 wing, we could actually get a much less trivial chain. So with H3 wings, we want to start off in a bi-value cell. So let's go ahead and start off with this cell, which has a 6 and a 9. And let's start off with the 9. It is strongly linked to the 6. And then we could weakly link this to this other bi-value cell with a 6 and a 7. So we'll go ahead and strongly link to that 7. So we've already covered both of our V links. That 7 is weakly linked to this 7 in the same box, and this 7 is bilocal in its row. So that is our L link. And this is a type 2 AIC because we started and ended on 2 different candidates. We started with a 9, so we can eliminate it from our ending cell. And all H3 wings are going to be type 2 AICs. So when it comes to spotting these H3 wings, we really want to look for 2 bi-value cells that see each other and share exactly one candidate. So in this case, those 2 bi-value cells are going to be these 2 cells, one which has a 6-7 and one which has a 6-9. And I apologize for the abundance of funny numbers here. I don't think that was the intention on part of whoever made this grid. But once we have these two cells, we could look at if either of the non-shared candidates sees a strong link. So looking at the nines, this nine doesn't directly see any strong links of nines, whereas this seven does see this strong link between these two sevens. So if we have these two bi-value cells and one of the non-shared candidates sees a strong link, and the end of that link sees our other cell, then we know we have an H3 wing on our hands and we can make that same elimination. But yeah, that is the H3 wing and our last H wing. So now that we've covered XY wings, L wings, S wings, W wings, M wings, and H wings, we've pretty exhaustively looked at all of the 5-link AICs. But what about 7-link ones? Well, there are too many to cover each instance of in this video, and as far as I can tell, most of them aren't even named, and they wouldn't be particularly useful to look for in the first place. However, one way of categorizing these 7-link chains is by looking at them as inversions of our 5-link chains. So if we took one of our 5-link chains and switched all of our strong links to weak links, that would make the starting and ending strong links into weak links, which would make it an invalid AIC, unless if we were to add an additional strong link, usually a location link, onto each end. And that is what we mean when we say inverted wings, because these are basically the opposite of the 5-link chains if we added an extra link on both ends. And these can be useful when we almost have one of our 5-link chains, but for some reason or another, it doesn't exactly work out. What we could look for is extending it a little bit on both ends to see if maybe we can get a hit that way. So here we have another example from the r/Sudoku subreddit. Let's go ahead and start off with this cell, which has a 1 and a 4. We could say this 1 is strongly linked to this 4, and this 4 is weakly linked to the 4s in this group of 2 4s right here. So let's go ahead and draw a box around those. So we could say this 4 is weakly linked to those 2 4s, and these 2 4s are strongly linked to this 4 down here. So we go ahead and draw that link. Which this 4 is weakly linked to this 4. And it almost looks like we have a W wing on our hands, right? We have this value link, we have a location link, and then finally we go to this cell, which is almost a bi-value cell, but it has 3 values instead. So we almost got that VLV structure, but we don't have it exactly. So instead of looking for a W wing here, let's go ahead and try to invert these links and see if maybe we can extend our chain a little bit and get a 7-link chain that works instead. And you'll notice we can actually validly switch all of our weak links to strong links and vice versa. So for example, if we treat this 1 to 4 here as a weak link, this 4 to this group of 2 4s is a strong link. That is valid. These 2 4s can be treated as weakly linked to this 4. And since this 4 is bilocal in this row, we could treat this as a strong link as well. And then we could weakly link it back to this 1. So this looks a lot like a W wing, except all of our links are the opposite. Now let's look at both of our 1s here. We'll notice both of our 1s are actually bilocal in their columns. So what we could do is we could actually extend this 5-link chain into a 7-link chain and make it a valid AIC by having it start and end on those strong links. And if we start on a 1 and end on a 1, we know we have a type 1 AIC, and we have cells that see both ends of that AIC. So the 1 in this cell and the 1 in this cell can be eliminated. So that is a type of inverted wing, specifically an inverted W wing. But you could pull off that same structure for any of the 5-link wings, as long as you switch all the strong links to weak links, and then you add a strong link on both ends. So with that, we conclude this part on multi-digit chains and wings. Huge shout out to Stormseeker from the r/Sudoku subreddit. He was the author of the article, which I used as a source for most of the grids in this video. And he also helped me understand H wings and inverted wings and kind of some of the history behind those and how they're defined the way they are. Anyway, we are going to be continuing this series. The next part is going to be on loops, forcing chains, and nets. So make sure to subscribe if you want to stay tuned for that, and like if you enjoyed the video. Thanks for watching.